we are using the FRB bars in bridge deck slabs or any other structural elements, but you know, because we have a corrosion problem actually. But in bridge, you know, we have a global phenomena here in Canada called bridge deck deterioration, which is occurred, you know, due to the excessive use of the icing salt and the freezing cycles. So in order to have a structural element, you know, for 100 year or 100 year and more, you know, with non-corrosive reinforcing bar like FRB, you know, this one will be a good solution to solve this this problem, you know, the deterioration problem in bridges. Yeah, you know, actually, we are talking, you know, here in terms of price. We are talking about flexural elements like slabs, and also we are talking, you know, about the price. You know, if you are going to use this kind of reinforcing bars, it will be very, very high, you know, compared to the black steel. So in order, you know, to save money and to have a durable structure, we can use FRB bars, you know, one of its type, you know, like GFRP, glass fiber reinforced polymer, carbon FRB, and you know, finally, it's based on the stiffness and the designer. You know, the designer should take a decision, you know, based on what he has, you know, from the acting loads and other events, you know, on the structure. Actually, you know, we have a very, very good advantage with FRB bar, which is the tensile strength. The tensile strength of the FRB bar is approximately, you know, like 4 times the yield stress in steel bars. In black steel bars, we have, you know, a field like 500. With FRB, we can reach like 1,500 tensile strength. And by the way, I would like to highlight, you know, on the difference between steel and FRB, as you mentioned, you know, in the first slides in the presentation, that in steel we have a yielding point. So in the design equations, we are using F yield. However, in FRB, we don't have yielding point. So we are going to use the tensile strength, which is 3 times the F yield. So with FRB, we are talking about a structural element designed with considering, you know, tensile strength. In steel reinforced concrete structures, we are designing the structures considering a field in the design equations. Actually, you know, the direct substitution between FRB and the steel, you know, is not valid, because we have high tensile strength, as I mentioned, but we have lower elastic modulus with FRB compared to that of steel. You know, in steel, we have elastic modulus of 200,000. In FRB, you know, we can reach like 65,000, you know, with GFRB. So we have lower elastic modulus. So, you know, we need to adopt the equations, you know, of steel sections, you know, to be valid for FRB by replacing, you know, taking into consideration the lower elastic modulus and the higher tensile strength of the FRB bar. So finally, you know, the difference between FRB reinforcing bar as a quantity compared to steel is not that much. You know, some people claimed it will be like doubled or something like this, but no. With a very good design, it's not that much. And you know, in terms of price, you can talk better than me. It will be, you know, in terms of price, they will be comparable. but you will have a very, very good service. You will have a durable structure for 100 years. You will have a safe structure also, because right now we have the Canadian standard CSA S806, and we have ACI 440.1R for the design of structural elements reinforced with FRB bars. And these codes are very, very alternative for the CSA 23.3 and the ACI 318. They are the same, but we took the equation from steel and adapted to be valid for FRB. So by comparing the quantity, it will not be very high. Let us say you are going to put in steel like 1. In FRB, you are going to put 1.2, 1.3. But the price at the end, based on the project, you will save a lot of money. And I can give you an example. There is a project called the Le Chancelier Parking Garage. And in this parking garage, they replace the deteriorated slabs using GFRP bars. And the city of Quebec decided to go with FRB rather than steel. You know why? Because the cost of FRB is very low compared to steel. How did they reach? Actually, they did a design with steel and FRB in order to compare, but they didn't use the membrane inside, the membrane inside the slab. So they ignored, the cost. They ignored the cost of the membrane, which is very, very high. So by ignoring this cost, you will have a very low, let us say low, I don't remember the numbers actually, but it's low, compared to steel.
Yeah.
So by using
I remember the study you're talking about. It costs about $60 per square meter of weatherproofing if you use black steel versus if you use GFRP, you save the $60 Canadian dollars per square meter. Sorry. So that translates to project. The city managed to save about $34,000.
exactly. This is what we are. We are. This is our message. This is our message, to the people, in the industry. If you have a problem and you would like to solve it, in terms of deterioration, go ahead and use GFRP bars. And the application of FRB bars in many structural elements, paved, is very, very successful. It's very, very successful. We have many projects here all over Canada, US, and other parts, all over the world, even in the Middle East, in Saudi Arabia, in Dubai, right now. And the weather, in these parts, is not cold like Canada.
Yeah.
But we have a direction to sustainability and durability, to have a sustainable and have a durable, buildings. So this is the reason, they target to use this kind of non-corrosive reinforcing bars. And the last thing I would like to say, the industry of FRB bars is getting higher and higher, in the standard. So right now, the specification to have a very good bar, is very, very high. Is very, very high. So by having a good bar like this, and I'm talking, in term, based on my previous previous experience by in testing this kind of materials, you know, under supervision of Professor Bumukhran at Sherbrooke University. The specifications are very, very high and tough, you know, in order to save people, you know, and have a durable structure, cost effectiveness also. Term is considered, you know, in this codes, the quality control. So everything, you know, is getting higher, you know, the specification is getting higher. And this is the reason, you know, a lot of engineers right now changing and their mind, you know, to use FRB bars instead of black steel. You know, we are always having this kind of questions, you know, from a steel guy, you know, the people who love steel, you know, in reinforced concrete structure and wouldn't like, you know, to change their mind. Actually, the research on this topic is still open in order to know the behavior of FRB-RC structural elements versus the steel one. And also, I would like to mention an example, you know, for these studies. A recent study, you know, at Sherbrooke University here, done on seismic cyclic loading on two-way slabs, and the drift capacity of these slabs exceeded the 1.5 drift ratio recommended for steel. So the drift ratio, you know, in FRB structural elements is little bit higher or equal the one with steel, you know, with the steel codes, because, you know, as I mentioned, we are adopting the steel codes to be used with FRB reinforcing bars. So based on the recent researches, you know, at Sherbrooke and at Manitoba, at Toronto University also, we have very, very good results, you know, in reaching a reasonable drift capacity in shear walls, in slabs, in many, many structural elements. But, you know, the term of ductility is not exist, you know, in FRB. Because Rick, you know, as you mentioned in the first slides, that FRB has no ductility or yielding point. So we have a term called deformability.
Yeah.
The term called deformability, and, you know, this term will give you an indication that your structural elements will be deformable, can go, you know, under some deformations like steel one. But we don't have the term of ductility. We have an alternative, you know, term which is called deformability. And, you know, we have an equation for this term in the Canadian standard S6, the code of bridges. We have this term in code of bridges, and, you know, this term is adopted from the steel one, considering the FRB tensile properties and other stuff, you know, in order to make this equation valid for FRB reinforced concrete elements.